Hi, this is from Dr. B. Vijay Kumar, HOD of Physics, Department of Physics, SNS College of Engineering. The another one topic to discuss from the unit of laser and fiber optics is semiconductor laser and its application. This is a special case of solid state laser because already we discussed solid state laser, Nd:AlG laser. So this is another one types of solid state laser. So the introduction of semiconductor laser, it becomes solid nature based on semiconductor gain media. The semiconductor laser we call this a laser diode. It is a device that causes laser oscillation by flowing an electric current to semiconductor. So the change of electric current from a semiconductor, it produces a laser. The mechanism of light emission is the same as a light emitting diode. When the two meet at the junction, an electron drop into a hole and light is emitted at the time. So the principle of the semiconductor laser is electroluminescence. The semiconductor is classified in two categories. One is in a direct band and another one is in an indirect band. And this semiconductor laser is form of direct band because the recombination of electron and holes take place directly, thereby emitting photon. It is used for laser action. So the two types of laser action is formed. One is in a homojunction and another one is in a heterojunction laser. The homojunction semiconductor laser, first we discuss the construction. The active medium is in a PN junction diode made up of a semiconducting material of gallium and arsenic. The P region and N region in the diode are obtained by doping germanium and tellurium form of gallium arsenic. So the thickness of the PN junction is very thin. The form of range is few microns. At the end face of the crystal are made partially reflecting to the form of optical resonators. So the edge of the crystal is act as a reflector. The electric current is applied to the crystal through metal electrode fixed on the upper and lower surface of the PN junction diode. So this is a picture to the form of how we form in the semiconducting laser. The top and bottom is a metal contact. It's connected from an injection of current, and P type region, N type region. So the both end it's form of the laser emission. So the power of the laser it become very low to compare in other types of laser in CO2 and Nd:AlG. This is the energy level diagram. So the population inversion is achieved by the injecting electron across the junction from the N region to the P region by the mean of a forward bias voltage. The recombination of electron and holes in region result in the emission of photon. The process is spontaneous and the laser radiation is random and is act on an incoherent formation. So the electron to move from the valency to the conduction band. So the valency band it's created in a free holes. So the in between of that barrier is called as an energy barrier. So we call this in form of a band gap energy. Photon trigger the stimulated emission of photon to get generated by increasing the rate of recombination electron and holes. So the radiation intensity will become increase. The wavelength emitted light radiation depend upon the concentration of donor and acceptor atom in gallium arsenic. So the energy gap of particular semiconductor is find it. The assignment, what is the principle of semiconductor laser and distinguish between homojunction and heterojunction. Why gallium arsenide is in a use for a semiconductor laser. So this is become is in a heterojunction picture. So the multiple layer to connected from in a gallium arsenic and also in aluminum gallium arsenic to the form of sandwich formation. The same in top and bottom is active metal contact to the connected in external power supply. So the light will be forward from the front portion of that. So the heterojunction laser have high efficiency. The various doping combination of gallium arsenic and aluminum gallium arsenic The P layer of gallium arsenic has an active region. The thickness is 0.1 to 0.2 micrometer. The both sides serve as a potential barrier and provide confinement for charge carriers to the flow of active regions. The excitation and recombination radiation can occur only within the active regions. So the laser structure carrier are confined to a narrow region. The population inversion is built up the total lower current levels. So this is also to be acting, the region is 1.1 to 1.6 micrometer. The operating current to required in less than 50 milliampere, and output power is also forming 10 milliwatts. So these are the characteristics of the semiconductor laser: types, active center, pumping method, power output, nature of output, and wavelength. Then advantages and disadvantages: very small in dimension, arrangement is simple, exhibit high efficiency. The output is usually in the form of wide beam, purity and monochromaticity are poor. This is application: defense and security, medicine and healthcare, commercial and entertainment, enforcement and scientific tech researchers. So these are the reference I prepared this PPT of semiconductor laser and its application. Thank you very much. We discussed in another one topic in another one video. Thank you.